Let's look at how to solve the surface area of a cylinder. So the formula for the surface area of a cylinder is defined as 2 pi r h plus 2 pi r squared. This might be a little difficult to remember, so I'm going to break it down for you so we can intuitively understand where this formula comes from. So you don't really even have to remember any formula. Let's imagine we have a piece of paper, rectangular piece of paper, right? And we roll this up. We roll this up into a hollow pipe, right? We're going to be left with a pipe of sorts. Now, this isn't a cylinder yet. Just like I said, it's still a pipe. To make it a cylinder, we need to add 2 end caps. We need 2 circles of the exact same dimensions on either side. Right? Now, this is a cylinder, and we can find its surface area. So look what we did. We took one rectangular or even square piece of paper, in this case it's a rectangle, right? A perfect two-dimensional rectangle, and we rolled it up. That gave the body of the cylinder, and then we just added 2 end caps, one on either side. The end caps are perfect circles, and the diameter of these end caps is the same as the diameter of our pipe, right? Or rather, this pipe. This is the piece of paper. So, to get the surface area of that cylinder, all we really need to do is to add the area of that original piece of paper before we folded it, before we rolled it up, rather, right? We just need the length times the width of this rectangular piece of paper, and 2 of the circles. Well, what of the circles? Of course, the area of the circles. And what is the formula for the area of a circle? It is pi r squared. And again, we need 2 of them. So plus 2 pi r squared, right? So if we're given any kind of cylinder, you can't just take the length and width of the unrolled version of this. So you have to do a little bit of math. You're usually given the diameter or the radius of the cylinder, right? But what we really need is this width. And this width is simply the circumference of the circle, right? And the formula for the circumference of a circle is 2 pi r. So that takes care of our width. And our length, in this case, is simply going to be the height of the cylinder, right? And again, to sum this all up, the surface area of the entire cylinder is going to be equal to this term plus this term. And that's how we get area to be 2 pi r h plus 2 pi r squared. So let's try to work on this example, the same as the last video. We have a cylinder with the base 1 meter and the height as 3 meters. So let's try to approach this as if we are going to kind of unravel this cylinder. So if we unravel this cylinder, we're going to be left with, again, the 2 end pieces, which are 2 two-dimensional circles, right? And we're going to get that rectangular sort of body of the cylinder. So let's deal with the body first. Again, we can't just get the width of that two-dimensional piece of paper, so we have to find the circumference of one of the end caps. So we know that the diameter is 1 meter. Therefore, the radius is 0.5 meters. And the circumference is equal to pi 2 pi r, which gives us, well, it gives us pi because the radius is 0.5 multiplied by 2 is 1, so we're just left with the pi here. So the circumference is equal to pi. or the width of that unraveled body is pi, and the length is going to be the height of the original cylinder, which is 3 meters. So the area of the unraveled body of the cylinder is going to be pi times 3 meters. Actually, it's pi meters times 3 meters, which is, let's say, 3 pi meters squared. And then we need to deal with the two end caps. So the areas of those end caps, let's deal with one of them actually, is going to be pi r squared, which is going to be pi times the radius, which was 0.5 meters squared. And our total surface area is going to be equal to 3 pi meters plus 2 of these end caps. Pi 0.5 meters squared. And if we plug all of this into a calculator, we'll find the surface area to be 10.995, but we'll round that up to 11 meters cubed.